zeolite, while oxygen will pass through the adsorber and exit as product gas. This takes place until the adsorber has reached its maximum adsorption capacity. Simultaneously, the second tank is depressurized to atmospheric pressure by opening valve V4. When the atmospheric pressure is reached, this valve V4 is closed. Just before the zeolite in the first tank becomes saturated with nitrogen, the process switches oxygen generation to the other adsorption tank, that is the second tank. So the inlet compressed air is diverted to the second adsorption tank through valve V2. At the same time, valve V1 gets closed. The inlet compressed air will take so much time to pressurize the second tank. To avoid this time delay, pressure equalization valve, that is valve V6, is opened so that the pressure in the first tank and the second tank equalizes. Now the second tank reaches the operating pressure and starts producing oxygen. A small portion of the generated oxygen of the second tank flows from top to bottom of the first tank, which is required to push out the nitrogen that was trapped in the zeolite. Now as the pressure inside the first tank reduces, the zeolite loses its ability to absorb nitrogen and starts releasing the remaining nitrogen that was absorbed earlier. This released nitrogen is vented out from the system through valve V3 and the zeolite becomes regenerated. By doing that, the system makes room for new nitrogen molecules to attach to the zeolite in the next adsorption phase. These operations are alternatively repeated in both the tanks, and the pressure is continually swinging between a high pressure at adsorption and a low pressure at regeneration, and hence the name pressure swing adsorption generator. The oxygen produced by the generator is stored in a buffer tank. From the buffer tank, oxygen is taken to the user end through a bacterial filter. An oxygen analyzer is used to check the purity of this produced oxygen. Oxygen booster is used to increase the pressure of the oxygen to meet various requirements of terminal user, and this oxygen booster is connected to cylinder refilling station where oxygen cylinders are refilled. Advantages of PSA oxygen generator over cryogenic oxygen plant. Investment cost of PSA generator is less than half of that of an equivalent cryogenic oxygen plant. PSA oxygen generator's startup time is only 5 minutes. Therefore, depending on the oxygen demand, generator can be switched on and off very conveniently. While cryogenic oxygen plant startup time is around 12 to 16 hours. So, cryogenic oxygen plant cannot be switched on and off